In this lecture, we're going to focus on instance attributes and how to work with them safely. We'll start by learning how to set instance attributes within the init method. This is where we initialize attributes specific to each object when it's created. Next, we'll explore how to modify these attributes after the object is created, allowing us to update the state of an object dynamically. Then, we'll move on to how we can dynamically add new attributes to an object, even if they weren't originally defined in the class. Finally, we'll discuss a safer approach to modifying attributes using methods. This adds control and validation to ensure attributes are updated correctly and in line with logical constraints. Let's begin by revisiting how we define instance attributes in a class. Remember, instance attributes are specific to each object, and we typically initialize them in the init method. We'll create a new file called carinstanceattributes.py inside the class folder. In this file, let's define a car class that has the instance attributes make, model, year, and mileage. Now that we've seen how to set attributes during initialization, let's move on to modifying attributes dynamically. This means updating an attribute's value after the object has been created. Let's see how this works by creating a car object and setting its mileage dynamically. In this case, the mileage was initialized to 0 for every new car object, but we're updating it dynamically to 5,000. Now, let's print the mileage of car 1 before and after it is updated. When we run this code, we'll see the car mileage before and after it is modified. After learning how to modify existing attributes, let's explore another possibility: adding new attributes dynamically, even if they weren't originally defined in the class. Python allows us to add attributes to objects at any time. For example, let's add a driver attribute to car 1. This adds a new attribute driver to the car1 object. Even though the car class didn't originally have a driver attribute, we can dynamically assign it. When we run the script, the output will indicate that the driver of car1 is Alice. This flexibility lets you adapt objects as needed, making Python very powerful for object-oriented programming. Having learned how to modify instance attributes directly, let's explore another common and safer method: modifying them via a function. This approach helps ensure changes are made in a more controlled and organized way, keeping your code cleaner and easier to maintain. For instance, imagine we want to update the mileage of a car. We could allow any value to be set directly, but what if someone accidentally sets the mileage to a lower number than it already is? That wouldn't make sense in real life, and it could cause issues in the logic of our program. To avoid this, we can create a method that updates the mileage with a simple rule: the new mileage must be greater than the current mileage. This gives us more control and helps prevent errors. Let's enhance our car class by adding this method to ensure safer updates to the mileage. This method includes a condition to check whether the new mileage is greater than the current mileage. If the condition is met, the mileage is updated. Otherwise, we display an error message. This way, we prevent invalid updates and ensure that the mileage can only move forward, which mirrors real-world behavior. Let's test this out. First, we'll try setting a valid mileage. Followed by an attempt to decrease the mileage. When we run the code, here's what happens. First, the mileage is updated to 15,000, which is a valid update because 15,000 is greater than the current mileage of 5,000. The update is successful and the new mileage is displayed. Next, we try to update the mileage to 1,000. This is invalid because 1,000 is less than the current mileage of 15,000. The function prevents this update, and instead of modifying the mileage, it prints an error message. After this invalid attempt, the mileage remains at 50,000. By using methods like this, we can ensure that our attributes are only updated in valid ways. It adds a layer of protection, especially when dealing with data that shouldn't be changed freely. This approach keeps your code cleaner, safer, and easier to maintain, while also ensuring logical consistency in your program. To summarize, in this lecture, we explored how to work with instance attributes. We started by learning how to set instance attributes within the init method, initializing values specific to each object. Then, we looked at how to modify these attributes after the object is created, giving us flexibility in updating the state of an object. Next, we saw how Python allows us to dynamically add new attributes to an object, even after it has been created. Finally, we focused on a safer way to modify attributes using methods, where we added validation to ensure changes are logically consistent. By understanding and applying these methods, we can make our code more robust and maintainable.